This video is on tree diagrams. Tree diagrams are used in probability when there's a lot of information. It's to help you really put it in an organized manner so you can find what exactly is you need. It's also when you have more than one event or more than one thing happening at the same time. So here an example is a bag contains 3 black balls and 5 white balls. Paul picks a ball at random from the bag and replaces it back in the bag. He mixes the balls in the bag and then picks another ball at random from the bag. So we're going to construct a probability tree of the problem. So we're going to make a tree diagram, and then we're going to calculate the probability that Paul picks is 2 black balls, and then we'll also figure out a black ball in his second draw. So what's happening here is we actually have multiple events instead of just picking one ball. So he's picking out 2 different ones. So a tree diagram will help us be able to organize exactly which draw what he gets on his first draw, what he gets on his second draw, and then we can determine which one, how many times he gets a black ball, how many times he gets a white ball, what the chances are of it happening. So to start a tree diagram, we start with a single point. So I'm actually going to start it over here. Then we have 2 different events. We have a not 2 different events, we have 2 different options. We have a black ball or a white ball. So we're going to draw 2 branches of our tree. And I'm going to use B and W. B for black, W for white. But then he also he puts them back in and he does another draw, which means he has 2 possibilities again. So he could have pulled out a black ball in his first try, and then he has another draw, which he could pull out a black ball or a white ball. But if he had pulled out a white ball in his first try, his second try, he could still have a chance to get a black ball or a white ball. So he only pulls out 2 different draws. So this is his first draw, this is his second draw. We would actually put the chance or the fractions, the probability on these lines so we can follow them. But then we can also see, as we follow them, we can see what the draws were. So for example, this, if we end right here, he had a black ball, and then if we follow the chart, he had a black ball first. So this actually, the set that this would be is he got a black ball first, then he got a black ball second. So that's the set of this draw, of these 2 draws. Well, if we have this one here, this set would include, if we follow back to the beginning, so we follow the lines back to the beginning, we get black ball first, then white ball. So B, then W. If we follow this one to the beginning, we got a white ball first, then a black ball. So we have WB. And this last one, he would have gotten a white ball, then a white ball. Now, the reason we want this and we want to know the set is because just like right here, 2 black balls, we know that we only have to find this answer for that question. A black ball on his second draw, well, that we have multiple of those, so we have to make sure we know which ones we have to calculate. So what we want to do is fill in the numbers as well. It says it has 3 black balls and 5 white balls. So this is a random chance. So for the black balls, he has 3 out of, there are 8 total balls in the bag. So we would say that this is 3 out of 8 chance of him getting a black ball. And then there's a 5 out of 8 chance of him getting a white ball. Because he replaces it, this is an independent event. That means that this chance of him getting another black ball will not increase or decrease because he put that original ball back in. So again, he'll have, to get on his second draw a black ball, he'll have 3 out of 8 chances. To get a white ball, he'll have 5 out of 8 chances. And again, on this branch, same thing. To get the black ball, he'll have 3 out of 8 chances. And then to get a white ball, he'll have 5 out of 8 chances again. So what we do is we have to make sure that these will add up together to be a 1 or 100%, because these are the two possibilities. So this is 3 out of 8 plus 5 out of 8 is 8 out of 8. On this branch right here, this is also 8 out of 8. And on these branches here is also 8 out of 8. So we've done that right. Now to go across this is an AND problem. This is 3 out of 8 and 3 out of 8 because we wanted to get a black ball and then another black ball. So we would multiply these. So this value here, this fraction, we're just going to deal with the fraction until we get to the probability. 3 out of 8 times 3 out of 8 is 9 out of 64. To get a black then a white ball, it would be 15 out of 64. To get a white then a black, it would be 15 out of 64. And then to get a white then white, it would be 25 out of 64. Now, since we have all of our possibilities, all of the possibilities should add up to, again, 100 or to a 1, basically. So we have the denominator of 64 on all of these. So 9 plus 15 plus 15 plus 25. So this is 25 plus 30 is 55. Plus 9 is 64. So it does, all of these would add up to 64 out of 64. So that means that our math is correct. So now that we have our tree diagram, we can actually go and answer each of the questions. So for part B, there are two parts. We have BI is to calculate the probability that Paul picks 2 black balls. So if we come over here, we want just the set of B then B, which we had as 9 over 64. So that's the fraction that represents that. And if we type it into our calculator and round it to 3 significant figures, so we have 9 divided by 64. 3 significant figures is you put your decimal, but we have it, our first natural number, which is 1, and then we want the next 2. We do have to round it on that third number, so we have 0.14, and then we'll turn this into a 1. So our chance of this happening is approximately 0.141 chance of it happening. Part B, double I, asks a black ball in his second draw. That there are different opportunities for that because he could get a black ball if he picks both of them black. So we have B and B, but we also have when he picked the white ball then the black ball. So we have also white then black. Now the black and black was 9 over 64, and then the white then black was the 15 out of 64. So we want the chance of this happening, and if we remember, if we add all these up, we have a 100% chance of us getting two balls if we draw out 2 different opportunities. So if I wanted to know the chance of us, or the probability of us getting 2 black balls and then a white ball then a black ball, I would add these 2 values together. So we would have, these would add to be 9 over 64 plus 15 over 64, which is really 24 over 64. Because again, all of these would have to add to 64 over 64. That would give us our probability of getting 2 draws, because that's what he's doing, is he is drawing 2 balls. So now we're just going to type in our calculator, 24 divided by 64. And we only have 3 digits, so this is our 3 significant figures. This is 0.375. So this is equal to 0.375. And that is our probability of him getting a black ball in his second draw. On this second example, it says a box contains 4 red and 2 blue chips. A chip is drawn at random and then replaced. A second chip is then drawn at random. So with that replaced, that tells us it's independent. So our second probability is not going to go up or down because based off of the first drawn chip. So part A says show all the possible outcomes using a probability tree diagram. So to draw our tree diagram, again, we're going to start at a single point. We have two different things that we can draw. We have a red and a blue. So then we have two branches. One's red, one's blue. I'm going to use an R for red and a B for blue. Then we're going to draw another chip, because it says a second chip is then drawn. And it says that it was replaced, so that means that our probability will not change. So we're going to have, if we pulled out a red chip the first time, we have a chance of getting a red chip and a blue chip again. Same thing if we had pulled out a blue. So now we can put a red chip here and a blue chip here. So again, we want to figure out the sets that we could have. On this first one, he would have pulled out a red and then a red. So this would have been the set of R, R. On the next one, it would have been pulled out an R, then a B, so it would be R, B. Next one would be blue, then red, so B, R. And then we would also have blue, blue. B, B. Again, we want to do this so that we can easily see what information it is that we want. So let's go and put our numbers in here. So we had 4 red and 2 blue, so that's 6 total chips. So for red, there were 4 out of 6 total. Now I could simplify this, but I'm just going to leave it as it is right now so that all of my denominators will end up being the same. Therefore, for the blue chip, it would be 2 out of 6 chance. And since it was replaced, I know that all the red and all the blue will have the same as the original. So for the next draw, the red would still have a 4 out of 6 chance, and the blue would have a 2 out of 6. The red would have a 4 out of 6, and the blue would have a 2 out of 6. So then we can actually find the fractions that would represent all of our sets. We would multiply from the branch to the branch. So 4 out of 6 times 4 out of 6 is 16 out of 36. For red then blue, it would be 8 out of 36. For blue then red, it would be 8 out of 36. And then for blue, blue, it would be 4 out of 36. So if we add these, this is 16 plus 8 is 32, plus 4 is 36. So these do add up to be a 1, so that's a 100% chance of us getting 2 chips. So now that we have our tree diagram set up, we can answer our questions. So we're going to calculate the probability of getting, so for BI, we want at least 1 blue. So what that means is anything that has a B in it, we will use. So this first one does not have a B, so we won't use it. But our first one is red, blue. We can use blue then red. So it would be an or situation in this case, because I could get this drawing, or I can get this next drawing of blue then red, or I can get the drawing of blue and blue together. So when it's an or situation, you add them up, and as we did on the last one, we had to add them if we had multiple of them together. So again, this is the red blue is going to be 8 out of 36. Plus blue then red was 8 out of 36, plus blue then blue was 4 out of 36. So that will give us 20 out of 36. So when we put this into our calculator, 20 divided by 36 will give us 0.5555 repeating. So we're going to, 3 significant figures, we're going to have approximately 0.556. That's just to get at least one blue chip. And if I wanted to make sure that I got doubles, or if I got 1 red chip, or any type of grouping they can be, I could ask what would the probability of it being. It's like for BII, I want 1 red and 1 blue. It does not tell me the order that I have to get it in. I just have to have a red and a blue inside the set. So not the first one, but this has a red and a blue, so I can have red first, then blue. Or I could have gotten blue first, then red. So we're going to add these again. So red and blue, then blue and red, that's 8 and 8, that's 16 out of 36. So this would be 16 out of 36. Put it into our calculator and rounding it to 3 significant figures would be 0.444. And the last one here is we want 2 of the same color. So BIII is asking for red, red, or blue, blue. Red, red, or blue, blue. Because it doesn't say we need to have 2 reds, but we have to have 2 of the same color. So red, red was 16 out of 36, and blue, blue was 4 out of 36. So that gives us 20 out of 36, which is the same probability of us getting at least 1 blue. So we're going to have approximately 0.556. So these are all probabilities that we could do without a tree diagram, but the tree diagram helps us to put it into sets so that we don't miss anything. This is one of the reasons why these can be beneficial in probabilities. So again, the tree diagram we use is an AND problem, but it helps us when we have an OR question inside of it as well. So on this last problem on this page, it says Jack wakes up late 3 days in every 5. So he's either going to wake up late or he's going to wake up on time. So how would we make this into a tree diagram? We only have one branch. So a tree diagram would have to have, or we had 2 branches. It would need to have a second thing happening. So if we continue on, if he wakes up late, the probability he is late for school. So not only is he waking up late, but he's also late for school. So those are 2 actual different things that are happening. So that's when we draw our tree diagram. We have to talk about him waking up late and getting to school late. So we have waking up late, he is late for school. Does not wake up late, he is late for school. So the 2 things you could have is he wakes up late, he does not wake up late, he's late for school, or he's not late for school. So we can kind of go along with if he wakes late, or he can wakes on time. Those are his 2 possibilities for him waking up. But then once he wakes up, he can either be late to school or he could be at school on time. So I'll write it out as he's at school late or he's at school on time. Same thing for this one. If he wakes on time, he can get to school late or he can get to school on time. So the information we're given is Jake wakes up late 3 days in every 5. So if our number for him waking up late would be 3 out of 5, and therefore for him waking up on time would be 2 out of 5. The next part says if Jack wakes up late, so we're going to go to here, the probability he is late for school, so this branch is 9 out of 10. So we put 9 out of 10 here. Therefore, this branch to get to school on time would have to be a 1 out of 10 because, again, each set of branches have to add up to a 1. So this would be 1 out of 10. The next line says if Jack does not wake up late, so this is where we're at, the probability he is late for school, so still going this way, would be 3 out of 10. So we'd put 3 out of 10 here. So then to get to school on time would be 7 out of 10. So then we can, the same way we did earlier, we can make our sets. It's kind of hard to write a set out when there's multiple things. So we can write out, we can say late, then late. Next one would be late, then on time. So I'll put L, then I'll put a T for being on time. Wakes on time would be time, but then you get to school late, so L. And then on time, and then on time, so I'll put double T. And then we can always find our fractions. So again, we would multiply, because this is an and, wakes late and gets to school late. So we would multiply. This is 3 times 9 is 27 over 50. wakes late, on time to school is 3 out of 50. If he wakes on time, then get to school late would be 6 out of 50. And then if he wakes on time and gets to school on time, that's a 14 out of 50 chance. So we have our entire tree diagram. Now we can go and answer the question. On what percent of days does Jack get to school on time? So we're focusing on the second column. We want on time. So we want if he wakes up late but gets to school on time, and if he wakes up on time and gets to school on time. So we would focus on both of these. So you can always, when it's saying get to school on time, if you don't have the sets written out, you can still find school on time and then school on time. And then we can just follow all the way back to the beginning. That's all we're really doing. And we just have these numbers. So we have the 14 out of 50 and the 3 out of 50. So again, because we have two possibilities, we would add these. So we would have 3 out of 50 plus 14 out of 50, which is equal to 17 out of 50. 17 out of 50 is going to be a 0.340. But it is asking for what percent of days. So we do need to change this back into a percentage, which is 34%. So we would say 34% of days Jack gets to school on time. So Jack does not get to school on time much at all. So again, tree diagrams are just to help us stay organized, especially when we have a lot of information, when there are multiple different outcomes, but could have some of the same information in it. So wakes late, but if he wakes up on time, he can still get to school on time in either scenario. So this helps us figure out that chance of that part happening, and then we combine it with the other one.